All right, so you guys got the shells of what was left over that I didn't post before? We got that? So, I swear I did it. Let me make sure. It does say that. Okay. So what the heck did I do? Let me do this. So again, I'm going to teach 2 sets of notes today so that we can have off on Monday. Okay? All right, so 5C is something that you guys, 5D is something that you guys probably could have just went through without me and been fine, right? So we started off with talking about multi-bar graphs, multi-line graphs, stack plots, right? And all this is doing is showing you guys different types of graph that you're going to see. We went over this one, which we talked about how that there's a lot of information within this graph, right? We showed that there was a title, right? We talked about how we label the y-axis and the x-axis, and that we have a legend, right? So that we know what we have here. Now, the thing of it is that we see the degrees, but we don't see what their job actually are, right, for men and women. Because based on this, you can say, hey, you know what? Men clearly get paid more than women. Then here's an argument. If I was to start a company, why wouldn't I hire all women? Because if I hire all women, I would save money, right? So there is something to be said about that as well, right? So it doesn't tell you what the job is, so therefore we could be talking about totally different things, right? If another female that has a master's degree, that like I do, have a master's degree, and they're financial advising versus me being a professor, guess who makes more money? She does. Same thing. If they were an engineer, if she was an engineer and I was a professor, guess what? She makes more money. However, a professor that has a master's degree, that's a female or a male, that worked the same years that I've worked, would make the same amount of money that I make. The only difference would be if they decide to teach less number of courses than I do, and they decide not to teach during the summer that I have made the decision of, then yes, I would make more money. But is it the fact that men get paid more than women? No. It's the fact that I'm teaching more classes, right? So I'm teaching a full load in the summer, which is 6 classes. Many of the professors are not teaching 6 classes over the summer. They might teach 1 or 2. They might teach a mini A and take a vacation for mini B, or vice versa. Or they might teach an online class so they can be out of town to a different location, or be on vacation while they're doing that, right? That's on them. I'm as busy as I am. That's on me, right? I only really need to teach, 4 to 5 classes every semester to be full-time. I think 4, really. But I decided to teach 6. which really comes out to be 7 because I'm a chair of a committee, so that counts as one class, right? So if I didn't teach that, if I didn't chair that one class, committee, then I would be teaching 7 classes instead. And if someone decided to teach 4, that's on them, right? So as much as this graph is great, it doesn't really help. And the other part of it is that, notice this label here. It says the median annual salary earnings. Not the mean, but the median. What's the difference between mean and median?
Mean is an average, median is the middle number.
Yeah. Median is the number in the middle. Right? So that has something to do with it as well, rather than a mean, which would be the average of all of them, which might be different than the median. This is a stack plot, right? Talks about the average estimate undergraduate budgets for full-time students. So it's not just tuition and fees, but the room and board, the books, the transportation, and other expenses. Yes, going to a private school is going to cost you more money. Room and board is more expensive. Right? Books and supplies are about the same. Transportation might be different. And the expenses should be about the same. Right? So you kind of have to look at what they're given to you, and that's why the legend is kind of important to have. I don't see a lot of these type of graphs, but they exist. So as the question says, what was the death rate of cardiovascular disease in 1980? So if you look at 1980, you see these separations, right? Looks like in the 1960s, it was a little bit wider because the cardiovascular disease was in the green, or is in the green, right? And by the looks of it, cancer is on the rise. It's still a stack graph. It's still a stack plot. They're just stacking all of them together, right? So, like, the total number of deaths is getting less, which makes sense, right? Because we have all these pharmaceuticals, right? That's supposed to make us live longer. But I guess the other question is, do you want to live longer when you're just lying in bed for the next 20 years? My ex's great-grandmother was literally in her bed for 20 years before she passed. What kind of life is that? Right? Yeah, so this is still a stack graph for sure. And then we have this right here. The energy use. Why are we so high? Or so low, I should say.
We're a populated state, so it's the amount of energy per person isn't as much, whereas in states like Wyoming and Alaska, it's not as populated.
It's how much oil you're using, right? I would think Florida's more solar, I would say.
A lot more electric than gas, right? Is there any oil in Alaska? Yeah. Is that where the oil pumps are? In fact, if you ever go up to Canada, Canada is a very interesting continent because going from one town to the next is literally like uninhibited lands. Right? They're very well known for their farming, a lot of farmland up there, and also oil up there. They are, yes. Because when you go further north, what happens? Way cold, just like Alaska, right? And it's funny because these towns, you got the major cities, right? Like Toronto and stuff like that. The other cities that you get to is pretty desolate. It's like, I remember I had to fly into, yes, it's spelled Regina, but it's pronounced Regina Airport. And I had to drive an hour and a half to get to this town that I was coaching in for summer camp and other camps as well. And during the summer camp, my drive an hour and a half, my windshield was covered, literally covered in mosquitoes. That's how many mosquitoes I killed in an hour and a half drive. And it's so cold up there. It's north of Montana. It's so cold up there that all of the rental cars has a plug outside of the hood. So you see the hood with a plug that flops outside of it. Because during the wintertime, they get to like negative 50. So you literally have to park and plug your car into an outlet so that the engine doesn't freeze. Yeah. So when you go to a place where you're like, I want to rent a car, and you see this electrical outlet that's flopping outside, there's a reason for it. Most likely it's in a very cold place when it's during the wintertime. So wintertime, no mosquitoes, but summertime. So wintertime, really, really cold. Summertime, whole lot of mosquitoes. I don't know why people want to live there, but there are people that live there. Saskatchewan is where I was. And then there's a contour map. So when people say that they want to live in California, understand that California has hot places and cold places. It's not as cold as Canada, but understand that. And a lot of times you see contour maps with like altitude. Very much times. And you have something like this, right? A 3D bar graph. But you got to be careful with distortion. And this is true. Our money is getting smaller and smaller. And it's funny because this reminds me of the first tattoo I got. I asked someone to draw me a tattoo to put on my back. When they drew it, it was going to cover from shoulder edge to shoulder edge, from my base of my neck all the way down to the top of my butt. I was like, hey, can you make it like half the size? And I wasn't thinking at the time what half the size is. Right? So if you think about something like this big, half the size you think is like this big, right? It's not, because half the length and half the width means it's a quarter of the size. Right? So if you look at these $2 bills of $1 versus 42 cents, right? It looks like a quarter of the bill. But it's closer to half, right? So realize half is the length half and the width half. But it's easy, really easy to look at the $2 bills and saying, oh, it's only a quarter. These two graphs here are the graph of the same thing. What did they do? Because the one on the right looks like it's pretty steady. The one on the left looks like a drastic change, doesn't it? Yeah. They basically shrunk the y-axis. And I'm going to say this, and it's going to sound weird. They shrunk the y-axis on the right. So the distance from 40 to 60 was shrunk on the right. So when you guys look at a graph and you're like, oh, this is not bad, it's pretty constant, look at the y-axis. Because that's what's going to tell you the story. When you invest money and they show you the, how the stock prices or the stock changes, look at the y-axis. Because someone can fool you if you don't actually pay attention. This looks like a pretty steady climb in population, yeah? Is it a steady climb? Look at the x-axis. Not necessarily.
You go from 120-year interval to 30 to 15 to 12 to 10 to 10 to 10 to 10.
Right? This is growing a lot faster than we think. Or I should say, yeah, growing a lot faster as we think. So this graph should look almost like much steeper. So that is 5D. That's what I was saying. There's not much to really write down there. 6A, however, now we're actually applying some work. Now we're going to be able to talk about skewing. So distribution is about the spread of the values. So the mean, as you guys were saying, is the average. So you add up all the values and divide by the number of values there are. The median, you got to first put them in order numerically from smallest to largest or largest to smallest, up to you. and then you take the number in the middle. Now, if there's two numbers in the middle, you would take the average of those two. So if you have 10 items put in order, that means it's going to be the average between number 5 and number 6. That would be the median. And the mode means the one that occurs most often. Now, every book is different when it comes to mode. Some books will say that you can have multiple modes. Some books will tell you that there's only one and only one mode. If there's multiple, then there's no mode. We will find out today which one this book decides on. So, here's data. Please find the mean, median, and mode. The mean, median, and mode. Everybody should be hacking away on their calculator right now. Unless you already did this. The mean should come out to be the median should come out to be, and the mode should come out to be whoa. Hey. Yes? What the heck is an outlier? Much lower or much higher? That could be called an outlier. meaning something that really skews the average. So for example, if I gave an exam and everybody got 100% and one person or two people got a 25%, those 25% would be the outlier, right? Because the average would be skewed. Majority of people got 100%. Only one or two people failed. Don't know why they failed when everybody else got 100. Maybe it's my teaching. I'm sure it is. Or at least they will blame it on my teaching. Those might be the students that are not in class either. But it's still my fault, I'm sure. So these are called distributions. Different shapes of distributions. If there's only one peak, then it's a unimodal. If it has two peaks, it'll be bimodal. But if the distribution is symmetrical, we call this normal distribution. And the mean, median, and mode are exactly the same. However, if the mean, median, and mode is not the same, like we saw on Monday, we could have the distribution either skewed left or skewed right. So notice how skewed left, the left side is lower. Skewed right, the right side is lower. So left skewed means the outliers on the low side, the left side. Right skewed means the outlier is a higher value. Everybody makes $30,000. There's that one person that makes $1 million. They're the outlier. That's going to be right skewed. Why are these graphs labeled the way they are? Why is the left one low variation and the right one high variation?
Low variation, you're only having to set things in a very specific group, so there's not a lot of variance. And the high variation is very spread out.
And if you guys learn anything about normal distribution, if this is my mean, median, mode, and if I was to have three standard deviations away, I can really only fit 2 right here. Notice how the variation is very, very close. Oh, dang it. I knew that was going to happen. But if I was to bring it over here and to create the 3 standard deviations, actually, let me keep it as 2 standard deviations. Notice that the spread of that is a lot higher. Okay. Any questions? Nothing? Should I finish the rest of the notes and next Wednesday we just talk about the review? Up to you guys. Okay. So consider the following wait times for 11 customers at 2 banks. Which bank will have more unhappy customers? You think Best Bank or Big Bank? So think about this. Usually, why do customers become unhappy? Even more, so if we look at Disney, right? For us regular folks that can't afford fast passes, right? When we get into a line, do we expect that line to be fast? Yeah. Not at all, right? We still wait. Now, what if let's take that same concept at a restaurant. You order food today, and you're like, 5 minutes later, food comes out. You're like, cool, I get to eat right away. Next day you go, it's like half an hour later, food comes out. You're like, what's taking them so long? Next time you come, it's like 15 minutes. Next time you come, 5 minutes. Next time you come, an hour. Would you be happier with that? Or every time you go to the restaurant, it's always 15 minutes? Because you know what to expect, right? There's not an inconsistency. You always know what to expect. So as much as people make fun of Chinese restaurants, 10 minute, 10 minute, 10 minute, bottom line is that people like Chinese restaurant. Why? Because it's always the same amount of time. Huh? Usually, right? But a lot of other restaurants will let the amount of customers they have change the time that they are serving. This is why Domino's Pizza got so popular, because at one point or another, they guarantee 30 minutes delivery. Or your pizza's free. That's what Domino's did. And they got popular for that because they're like, okay, cool. This is a busy time of the night. Let's call them. Let's see if we can get a free pizza. And it gets delivered. Dang it, but at least you know it's going to be there. If you call another place, one time we'll be like, okay, we'll be there in 15 minutes. And another time is like an hour and a half. And you're like, what? I can get food for myself in an hour and a half. I don't need to wait for your pizza, right? So, yeah. So in this case, the big bank will be having more unhappy customers because the wait times is different. It's inconsistent, right? More variation. as we just talked about variation. Where best bank, we know what to expect. It's going to be 7, 8 minutes. But I know that 7, 8 minutes, I'm going to be able to get out of there. With big bank, I'm flipping a coin. I have no idea. The range of data is your largest value minus your lowest value. That's the range. So the test scores that I was talking about, the range was 100 minus 25. So it's a spread of 75, or the range of 75 points. We're about to jump into something called a box and whisker plot. If you look at the word quartile, you should think of the word quarter. So the lower quartile is the bottom fourth or bottom quarter of the values. Middle quartile will be the middle quarter, meaning half, which is essentially the median. And the upper quartile is the upper 25%, which that will be 3 of your 5-number summary. The box and whisker plot is also known as just a box plot. So essentially what you're going to have is something like this. That's what a box plot is going to look like. Obviously not perfect like that. It's never perfect like that. This is why it's also called box and whisker plot, because those 2 lines are your whiskers. What does that come out to be? 6.9? let's do a box and whisker plot for this. So what am I looking for? Yeah, I should do it all to the right. Here, I'll do your low and high value for you. I'll even do your medium for you. Might be easier for you guys did this. That'll be nice. Mm-mm. What is the lower quartile? What's the matter? Huh? No. It's like the median between those 5 values. It's like the median of those 5 values. So you got the median, and then you're doing the median of the median, and the median of the median. Or I should say, the median of the lower half, and the median of the upper half. Oh boy. And when we talk about variation, we're talking about, I should say, the square root of the variation is called the standard deviation. You got to do all 5 steps. So the question is, can I find some data for you guys to do this? What am I doing? Oh gosh. I do. So let's do this. Let's say that my data is going to be 37, 43, 47, 53, and 57. So first I gotta find the mean. Which we typically call X bar. Are we okay? Yes? The second step says, well, it's still the first step actually. It says deviation from the mean, data value minus mean. What does that mean? That means I'm going to create a table here. The data value is my values, which would be 37, 43, 47, 53, and 57. I'm going to write down my mean, which was 47.4. Yes, I'm going to write that for every single one of these. And again, this is still step 1, guys. Data value minus mean. That's what this is saying. Data value minus mean. Yes, you're going to get negative values. It is okay. So that is all step 1. We just got step 1 done. Okay? We good so far? What is step 2? Find the squares of all the deviations from the mean. What does that mean? Square each one of them. So we got to take this, and we have to square it. Negative 10.4 squared. Negative 4.4 squared. Negative 0.4 squared. 5.6 squared. 9.6 squared. That is your step 3. I'm sorry, step 2. Okay? What's step 3 say? Add all the squares of the deviation. So I have to add all those numbers up. Okay? Actually, you know what I should do? There we go. All right, step 3 is done. Step 4, divide this sum by the total number of data values minus 1. How many data values do we have? No. 5. Because this is the data I was given. There's only 5 values. All of these, yeah. That's not it, right? Because that's why when you guys are reading this, you have to remember that they're using the same verbiage over and over. Data value minus mean. So this is the data value. This is the mean. So data value minus the mean is this right here. Right? So now for step 4, I got to take this number here and divide it by the number of data value. Step 5 says the standard deviation is the square root of this quotient. That is the standard deviation. So yes, that's what you have to do to find the standard deviation. So I just walked you through these 5 steps there. And notice that these 5 steps is in the equation. Right? Step 1 was to essentially find that. So you had to find the mean and then deviation from the mean. So the data value minus the mean. And square it. Then sum that whole thing up. Then divide it by the number of values minus 1. Then take the square root of it. Questions? The standard deviation is approximately related to the range of a distribution by the range rule of thumb. Standard deviation is about the range divided by 4. What's the range there?
20.
Divide by 4 is? Wow, so close. So realize that it's very approximate. Very, very approximate. Now, when there's much more values there, then it's going to get closer and closer to it. But when you only have 5, very slim chance that that's going to happen. Okay? If we know the standard deviation of the data, we can estimate the low and the high values as follow. Low value is about the mean minus 2 standard deviations, and the high value is the mean plus 2 standard deviations. So, studies of the gas mileage of a Prius under varying driving conditions show that it gets a mean of 45 miles per gallon with a standard deviation of 4 miles per gallon. Estimate the minimum and maximum gas mileage that you can expect under ordinary driving conditions. And you got?
Maximum 53, minimum 37.
And where did you get that from? Any questions?
I have a question.
Yep.
For the low value approximation, would we use that, or how would you do it? It says is it 2 times the standard deviation minus or plus the mean, like that way?
So most likely it will be asking a question where they're asking for the minimum and the maximum, right? They're going to give you the mean and the standard deviation.
Okay.
Yeah, most likely that's what's going to happen. Huh?
Is the standard deviation times 2?
Yes.
Then okay, that's correct.
Yep. Yep. And the reason why they're using 2 is because based on a normal distribution, 2 standard deviations away takes care of about 95% of the population. 3 standard deviations away is only, what is it, 97 point something? Or is it 98?
Okay.
Right? So going 3 standard deviation, you're only adding a very small amount. So why go 3? The 2 is going to take out the majority of the population anyways. Like, is there going to be some that's going to be less than 37, some more than 53? Yes. But it's going to be such a small percentage. It's like trying to hit a dart in a very small target.
Okay.
So, yep. And notice that it's talking about Prius under varying driving conditions. So remember that this is much larger population than if it was 5 data points, right? So that's the reason why the estimate is possible. All right. Any other questions? All right. So again, no class on Monday. See you guys Wednesday. And hopefully by Monday I will have the review up. If the review is not up, can someone please message me to remind me? Is that fair? Okay. Same thing with this. If I told you I was going to let you guys out early because I'm going to post this, this, and this, if it doesn't get posted, please remind me. I'm just human. Sometimes I make human mistakes. And sometimes as a human, I forget. So I don't mind the reminder. So please don't think it's a bother by any means. Okay? On that, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. I'll see you guys next Wednesday. Later.